is this is the function we're working with. We know that the derivative of the product, let's call it f times g, we can use the power rule on that. So the derivative should be 8 times 6, 48, times x to the 7th. That is definitely right. This is most definitely wrong. Now we know this is right because it's based on two facts that we know about. We know that to multiply the functions, that's an established mathematical law, that you just multiply the numbers in front, add the exponents, and that's how you do that. And then we've got the power rule that we just talked about, so that's got to be right. This we were just kind of guessing. And as you can see, that does not work in general. Okay? So the question is, what do you do with products? Well, if it's this easy, obviously you just multiply the functions together and you just find the derivative of their product. But some functions, it's hard to multiply them together, or impossible to actually multiply them together and change the form. Okay? So this is the rule, it's called the product rule. The derivative of f of x times g of x, make sure you write this down in your notes, is f of x times g prime of x plus g of x times f prime of x. Okay? So it's a little complicated and it looks overwhelming and intimidating, but unfortunately this is the rule for dealing with products. If I call f the first function and g the second function, to do the derivative of the product, you just take the first times the derivative of the second, plus the second times the derivative of the first. Okay? And again, when I get back, I'll show you a formal proof of why this works. It's a little tricky. It'll probably take another 15 minutes to show it, so I'm going to spare you that today. Okay? Another way that you'll see this represented in some books or other resources, instead of having f of x and g of x, they use u and v to stand for the two functions. So u is the first function, v is the second. And so they'll do u v prime plus v u prime. Okay, same kind of thing. First derivative second plus second derivative first. Or you might see u times dv dx plus v times du dx. All mean the exact same thing. Okay, v prime is the same as dv dx, just a different form of the derivative notation. U prime is du dx. Okay? So that's the product rule. So let's actually use it on an example. Now, going back to our last problem, let's go back and do that simple example before we look at a harder one. We said that f of x was equal to, what was it again? 3x to the fifth. And g of x was equal to 2x cubed. Now we know that we could just multiply them together, but let's actually use the product rule. So the derivative of the product, f times g, using the product rule, is the first function, 3x to the fifth, times the derivative of the second, which is 6x squared, plus the second function, 2x cubed, times the derivative of the first, which is 15x to the fourth. Now to simplify this, I'm going to combine the expressions either side of the plus. Okay, so I'm going to do the multiplications before I add. So when I multiply these together, I get 18x to the 7th, plus, over here I get 30x to the 7th, which, those are like terms, put them together, you get 48x to the 7th, which is the answer that we said was right last time. Okay? So that's just an explanation that this product rule actually works. Okay? Now, when would we actually use the product rule? Let me show you an example. So I'll do one, and then I'll give you one to do, and then I'll give you guys some time to work on your homework. Yeah, I'll give you guys time to work on your homework. Like, I have any control what you do since I'm not even in class. But the substitute, the very nice, handsome substitute, will give you time to work. Okay? So here is an example of when you would use the product rule. Let's say you have this function. I'm going to keep it pretty simple today. We'll get into more complicated functions later. Okay. So let's say we have a function that's defined as a product. Okay. And we're asked to find f prime of 2, let's say. Well, we could actually multiply this out. Binomial times trinomial. You'd have to take this times and distribute it, everything times everything else. And that's pretty much a pain too. So you gotta get your choice. You want to use the product rule or you want to multiply everything out. In this particular case, it's a pain to multiply everything out. And there's some situations you'll see later where you actually can't multiply them or simplify in any way. So to use the product rule, here's how it works. We take the first function, 3x plus 6, and multiply by the derivative of the second. Now notice that I'm using parentheses here because the terms are not single, each part is not a single term. So I have to group the terms together with parentheses. First function times the derivative of the second. The derivative of the second is 4x minus 8. Plus the second function, 2x squared minus 8x plus 1, times the derivative of the first, which is 3. Now to simplify, I still have to do some work here. I have to FOIL this, distribute the 3, but that's a little easier than what we started with, a little bit. So if I FOIL this out, I get 12x squared. Outside is negative 24. Inside is positive 24. Could that really work out that nicely? I guess it does. Then we get minus 48. Okay. And double checking myself here. Oh, that's right. I'm doing a different example than I thought. Okay, so 12x squared minus 48 plus, then I distribute the 3, be 6x squared minus 24x plus 3. Combine the like terms, so we got 12x squared and 6x squared is 18x squared minus 24x, and then 48 and a 3 combined to make minus 45. And that's your general derivative function. Okay? So then the last step, since we were trying to find f prime of 2, is to plug in the 2. So we get 18 times 2 squared minus 24 times 2 minus 45. And I even think I can do this with a calculator, maybe. So 2 squared is 4. 4 times 18 is 72. Minus 24 times 2 is 48. Minus 45. And maybe I can't do this in my head. Let's see here. This would be 72 minus 48 would give me 24. 24 minus 45 would be negative 21. So that would be my derivative. Forgive me if I made a arithmetic mistake there. Okay? So sometimes you actually have to use the product rule. So I want you guys to do one real quick before we